Hi, and welcome to the Fireside Chat on Security session. My name is Victoria, and I work at Cisco. I have today with me Bram, who is a security advocate at Bluecode. We care about security, and well, so do you, as you are here. This session is about the security on the beam. Today, we are going to cover three topics: threats, solutions, and unsolved challenges. We want to engage you in our discussion during the session, so whenever you have a question, please just post them in the Q&A tab on the Google, and we will pause after each topic and answer your questions. There is no such thing as wrong question, so don't overthink it, just post it, please. All right. So let's start with a bit of history. Did you know that Erlang was designed to be used on closed networks without any external access? Well, it was, and we can notice that this is not how we use Erlang today. But does this mean that Erlang is less secure than other programming languages? What is your view on that, Bram?
Yeah, well, it's of course a bit simplistic to think about a programming language or a platform a framework as being secure or insecure. You can write secure code or insecure code in any language. So I guess different languages, different tools have different benefits. And they might make certain things easier while at the same time making certain things harder, and that applies to security as well.
Yeah, and what would be the benefits of using Erlang compared to other languages?
Okay, so like one of the things that's one of the easy answer is, of course, like if you compare Erlang to languages with manual memory management, such as C. So in C, you have to be very careful to not introduce memory bugs such as buffer overflows. You know, those can be devastating for security. And if you are responsible for checking all the buffer sizes or stack overflows or underflows, if you have to think about that with every line of code that you write, that's a liability. Whereas in dynamic memory management language like Erlang, there's still a lot of C code under the hood. Of course, Beam is written in C. Some NIFs might be written in C, the operating system. But at least the code that you and I write every day is very unlikely to introduce any such issues. But of course, Erlang has that in common with many other languages these days. So I think beyond that, I think immutability has some benefits compared to languages that have a global mutable state, which can introduce some very subtle bugs that might be not easy to exploit, but they could have very severe consequences. You could have, for example, double spending if like two processes at the same time try to spend from a single account, and you don't have proper locking in place with that. Just as an example, so immutability can probably provide some benefits, and I think the actor model also with supervision gives you some extra resilience, which is also a security aspect. Okay, resilience against denial of service, basically availability of your service, and not having to think about that from the beginning because it's provided by the platform is a huge benefit. It won't stop distributed denial of service attack, but it will give you a head start where it's not so easy for someone to make like a single request that basically stops your system.
Right. But immutability, does it only gives you good things, or does it give you bad things as well?
Yes, well, it does make certain things harder. So in particular, when it comes to protecting sensitive data. So in other languages, you might be told to zero out a private key after you've used it, for example, so that it doesn't linger in memory. It doesn't end up written to disk in a core dump, for example. And you just cannot do that in Erlang. If you're done with some data, you just have to hope that the garbage collector will release it and will end up allocating it for something else, and then eventually overwriting it. And there are other. This is an area that I've noticed is probably the biggest challenge generally in Erlang, is like protecting sensitive data, because also in a functional programming language you end up passing a lot of information around as function arguments, because you just can't reach out into global states the way you do in other languages. So with that, you pass around maybe credentials or keys or sensitive information about your end users, and this data can end up in a crash dump, or rather in a exception, in a stack trace, which then might end up in your logs, which might end up being sent to something like Sentry. And to protect that data can be a challenge.
Yeah, it is challenging, right? Well, one practical way to do that, right, is that you wrap it into a font, the sensitive data, so that then what is going to be printed out is that there is a font expression there, and not the sensitive data itself. But of course, it's not a silver bullet; it's just a bullet. All right. I wonder. So, is there any threat that is specific to Erlang? Like, I don't know.
Something that any Erlang or Elixir or other Beam application needs to be aware of. So yeah, there are definitely common issues. So the first one that is often mentioned in this context is atom exhaustion. So you should never create atoms from user input. I think everyone knows that by now. Still, you find cases of that, particularly because you are not always in control. Maybe you pass the information you get from a user into some library, which then passes it to XML, which turns it into atoms as part of XML parsing or things like that. So it's still an important issue. And another area that's always a challenge is SSL. So people sometimes ask me, should I terminate TLS in the Beam application, or should I put a load balancer in front? So we can argue about that, but when it comes to clients that need to talk to a database, to a HTTP API or some other service, you don't have much choice. You have to use the SSL client that comes with Erlang OTP standard library, and it has some challenges. And I've seen a lot of cases where clients in particular are not properly configured, and they end up not verifying the server certificate. So that's something to be very careful about. I don't have time to go into all the details now, but I've done previous talks that we can probably link to at the end.
Yes, and at the end, we are going to give you all the resources that we talk about today. So you will have a lot of links and documents to read. That's correct. So going back to the atom exhaustion, so how are atoms stored in Erlang, and why can't we exhaust it? And is it only atoms that we can exhaust?
Well, so okay, that's two questions. First question, so atoms, basically atoms are not garbage collected, and I guess it would be difficult to garbage collect, not impossible. I guess it's just a simplification for the VM, and if you use atoms the way they're intended, then you should never really have to worry about it. There shouldn't be a need. Some would argue there's no need for garbage collecting atoms if you use atoms as they are supposed to be used. There have been various initiatives in the past to maybe add garbage collection. You have to be careful, especially in the context of a cluster where all the cluster nodes have their own atom tables, and you want to be able in the wire protocol between them to reference atoms by index easily. So that might potentially make it a bit harder to do garbage collection for atoms. But it's not just atoms. I mean, the whole VM can also run out of memory, and you can talk about supervision strategies to keep the application running even when things go bad. But if you run out of memory, the VM, just like any other application, will just crash. So, and it's hard to protect against that. Like to put hard protections in place. You can, of course, make your application more memory efficient, but you can never really be sure that you will never run out of memory.
Yeah, right. Memory is a is a thing that's total constant for a running system. That's correct. But okay. So what about Elixir? Do we have there anything that's like specific threats that we don't have in Erlang, for instance?
Yes, I think so. That obviously anything that applies to Erlang applies equally to Elixir. There are things that Elixir does that a bit differently, and in particular, Elixir tries to be maybe a bit more, I don't know, a bit smarter and do things automatically that in Erlang you have to do manually, which a lot of Erlang people would argue is probably better to do things, keep things explicit rather than doing things implicit. And that's definitely true when it comes to security. I mean, you can get bitten by things that happen that you might not even be aware that they are happening. So, and a specific example would be the protocols, which are basically an Erlang or an Elixir feature that lets you implement what's the word I'm looking for? Implement behaviors for different data types, but common behaviors. For example, the enum protocol lets you iterate over data structures, and there have been cases in the past where this was actually abused to achieve code execution, because anonymous functions implement the enumerable protocol. So there was a vulnerability in plug in the session management plug that could be exploited. The plug was expecting to, or if your application was expecting to find like a list of data in your HTTP session, and you were trying to iterate over it using the functions in the enum module, if an attacker managed to actually plant an anonymous function in your session instead, that function would be invoked, and that's something that would just not happen in Erlang, I think, because it doesn't have these kind of mechanisms. If you can still have code execution vulnerabilities if you deserialize an Erlang term format and then invoke a function that you find in it, but at least you should be aware that you're doing something very dangerous there.
Yeah. Well, I mean, if you deserialize something and you executed it, you basically asked for it. So that's
right. So the implicit execution in Elixir opens up another risk, I guess.
Exactly. But okay, so okay, so in Erlang, when I try to communicate with the host that runs the Erlang node, then right, I use commands that touch on the operating systems. So we know that OS command doesn't escape the command itself. It's left to the user. But is there any other way to do that so that we don't suffer from bash injections, so to say?
Well, so this is actually an example where Elixir, because it came along a little bit later and it had a chance to review the standard library and maybe prevent issues that exist in Erlang and that are difficult to fix in Erlang for backward compatibility. So the Elixir equivalent of OS command execution actually uses a port, and when you open a port to an external command, you actually have an option to select, to specify the executable that you want to run and the list of arguments that you want to pass to it. And that's the proper way to do it, because that avoids the injection issues that you have with OSCMD. And the Elixir standard library makes that very convenient to use, because they take care of all the opening the port, passing the data in, getting the data out again. And so in Erlang, you'll have to do that yourself, or maybe use a library that does that for you. Now, this is actually a topic that's covered in the secure coding guidelines of the Erlang Ecosystem Foundation Security Working Group. So that's something I want to mention. We'll probably get to it again later, but it shows examples of what can go wrong and how you can protect against it.
All right. So Raimo had a comment to us saying, like, I would say clearing work memory is a bit security theater, since the operating system, cache handling and such still may leak information. Do you have any comment on that?
Yes, of course. I mean, in security, it's always very difficult to say which mitigations are effective and which ones are there, like, for compliance reasons or to give yourself a false sense of security. So it's a tool in a toolbox, right? It's in practice, is it very effective? I don't know. But if you look at in a large organization, you might have a list of, like, a checklist of things that you must do when you if you want to deploy an application to production. And this might be one of the things in your checklist. And then you can go and try and argue with whoever needs to sign off on exemptions that actually in Erlang it's fine, don't worry, this is not a very important mitigation, but it's usually easier if you have the ability to actually implement the mitigation to just say, okay, compliance, we will implement the mitigation, whether or not it will actually save us one day, I don't know, but then you just avoid the argument. And if you just cannot implement the mitigation, then you have to have that argument, whoever imposed it on.
Yeah, right. All right. Right, as Raimo posted questions, so can you, all of you who joined the session, and please do during the session, and I will pick sometimes a few questions and ask Bram about it. Right. Let's touch a bit upon the distribution protocol that Erlang provides, right? So it's distribution is built into the language. We can very easily set up a Erlang cluster. We can distribute work, we can distribute load, but how can we do that in the secure way, or is it secure by default?
Well, so as you mentioned at the beginning, when Erlang was first designed, and when the distribution protocol was first designed, the use case, of course, was very different from what we might use Erlang for today. So in a central office of a telco, you're behind like 3 firewalls, you're behind a locked door with a security guard or a pass reader. That this is a closed environment where these applications were running, and the distribution protocol was mostly to allow maybe the active and the standby card to communicate with each other within a chassis over the backplane. So that's very different from, for example, running a cluster of Erlang nodes in the cloud, and maybe even doing cross availability zone distribution. Like if you're running an AWS cloud and you want to host an instance in 2 or 3 different availability zones, but still leverage the Erlang distribution protocol, you're going to have to think a little bit harder about how to secure it. And they're leaving aside issues of latency, whether it's actually suitable for this kind of distributed applications in the first place, when the latency might be a little longer and the network availability might not be quite 100%. But in terms of security, so first thing is the communication is completely unencrypted. So it means that any data that gets transmitted can be sniffed by whoever sits on the network. You might be able to solve that with VPNs or something like that, or you can basically replace the TCP distribution with TLS distribution, or actually they call it SSL distribution because of the SSL application in the Erlang standard library, which gives you the benefit of encryption, but it also lets you do stronger authentication, because the standard authentication of the distribution protocol using cookies is, cookies aren't a very strong authentication mechanism, and a man in the middle can, for example, just inject themselves between two nodes that are trying to authenticate themselves with cookies and just become part of the authenticated session without really doing anything, just forwarding the messages. If you have a need for, like, I would say generally don't use the distribution protocol in an environment that you cannot 100% trust. So if you're building like embedded devices that go out into the world and connect in IoT networks in strange places, don't use the distribution protocol at all. If you choose to use it, and you cannot be 100% sure that your network is closed and protected, use the SSL version of the distribution protocol, which is not trivial to set up.
Sure. But you have that option, so that's already great. I think it's it's not with us from the beginning of Erlang, so it's a great addition to the language, I believe. Thomas has a question that says, what is the state of PIE in Erlang now? Is it on by default in most builds, or do we have to specify it still?
Okay, that really depends on where you get your binaries. So first of all, PIE, it means for position independent executable. And it's what allows the operating system to run your application with address space layout randomization, or ASLR. And remember we talked in the beginning about buffer overflows and the fact that your Erlang code shouldn't introduce buffer overflow vulnerabilities or similar vulnerabilities, but the beam and the NIFs and the BIFs are still C code for the most part, and therefore address space layout randomization can still help you protect against certain memory issues that may exist in those layers of the application. So it's generally best practice for all your applications on any kind of platform to run with address space layout randomization. This used to be an issue. A lot of the binaries that you would find from Erlang solutions at the time and from the operating system distributions did not compile Erlang as PIE, maybe partly because high performance Erlang, before there was the just-in-time compiler, didn't like it for obvious reasons, because you're basically generating code, and that code needs to also be position independent. So it used to be an issue. Nowadays, most of the binaries that I've checked from operating systems and from, for example, Bob the Builder, which is the Hex service that builds binaries and Docker images. So they have position independent executables by default. There is a tool to verify it if you want to be sure, especially if you compile your own. I think also the make files have been updated in most cases to so that it will be enabled by default.
Right, and now that we started to talk about tools, so let's move to the second topic, which is solutions. So we now learn about the threats. We know that we need to protect our Erlang node. So us as engineers, what can we do to mitigate threats? Are there, for instance, some processes that can help us to ensure securities in all stages, and are those processes really for everyone, or what's your take on that?
Yes, I do think, as developers, as engineers, we sometimes dislike processes because they slow us down. But I think when it comes to security, I do think it's important to have something in place. Like, you have to think about some ways of prioritizing your efforts, right? And in a large company, maybe there will be some processes imposed upon you. In a small company, if you're a small startup, or if you're working by yourself, then probably you won't have anything like that. But I would definitely recommend researching that a bit. There's, for example, the OWASP project has a one of their programs is one of their projects is the Software Assurance Maturity Model, SAMM, SAMM, and that's basically a tool that helps you kind of check where you are in terms of your secure software development lifecycle. Like what kind of tools do you use, and which part of the development lifecycle, all the way from requirements through design, implementation, testing, deployment, and you know, how can you improve over time? So there's a strong focus on basically coming back to it every now and then and say, okay, am I improving? I may not be perfect. You'll never be perfect, but am I improving? And am I expending my limited resources in the right places? Because, you know, as engineers, it's very easy to get bogged down on like one small thing. For example, there's a tool called SSL Labs, right? SSL Labs, you give it the URL of your server, and it will check if your TLS configuration is strong, if your certificates are correctly configured, and then it will give you a score. And that might be a C or a B or an A or an A+. And then, you know, as an engineer, you are trying, okay, I got to B. Now how do I get to A? And how do I get to A+? And then, oh, I have to enable OCSP stapling. I have to disable another cipher suite. And at some point, you get to the area of diminishing returns where you're basically expending effort, which you probably don't have you don't have unlimited time to work on this stuff, right? You actually have customer requirements to meet. So it's easy to get bogged down on little things like that, when actually the big wins are completely somewhere else. Like in most organizations, the first thing I would look at is things like, are my employees aware of phishing, of malware? You know, are my dependencies up to date? Those are probably the things that you can have like easy progress, and then you can worry about those other smaller things later.
All right. Yeah. So we all need to have a security aware mindset. It's maybe it's not the best goal or tactic to have one security advocate and trust that, right? All engineers should have it, and I guess from day zero. So you should have it from when you just started to design your application. Maybe when you are coding, it's already a bit too late. Not that like it's not fixable, but yeah. And there is an interesting thing that you mentioned, like dependencies. So it is very easy to add the third-party application to Erlang and Elixir, right? So in Rebar or using Mix, it's super easy to do that. But can we trust those dependencies by ourselves or by default, right? Or what should we do with it? And yeah, what's your suggestion there?
Yeah, so obviously dependencies can spiral out of control very quickly. Especially we see that on the front end with Node.js or not Node.js, npm packages. But also, you know, any non-trivial Erlang or Elixir application will bring in a bunch of dependencies. And I think the first step is to make sure that you actually know what you're using. To have what's called a software bill of material, so that you can say, okay, yes, I am using this, or no, I am not using this, or no, I am not using the version that was just discovered to have a vulnerability. And so there's tooling that can help with that. It's also important, by the way, for license compliance, because you know, if you have 50 or 200 dependencies in your application, how do you know that you're not violating some license constraints that some of these dependencies impose? So having that data, having this bill of materials is I think very important. And then there are tools that will help you based on such a bill of material, based on that inventory, will also warn you of known vulnerabilities in those applications. your question, how do we know we can trust all these dependencies? Yeah, how indeed? And the fact that everyone else is using them is often used as an excuse. Hopefully, that the fact that lots of people are using them means that there's some scrutiny and that the community will review these packages. At the end of the day, you have a responsibility as a developer who brings in a new dependency to go and check it out and do some audit. And even if you don't read every line of code, you would still maybe check the credentials of the authors. Are these trusted people in the community, or did this pop up out of nowhere? So that's a very difficult topic in general, but that's not specific to Erlanger Elixir.
Yeah, right. So exactly, and well, we have like a lot of tools to use, right? We have PAST, we have the Elixir linter, we have a Phoenix specific tool as well. We have Erlang specific security checkers as well available. We will post all these resources again on the chat tab. We will find it after the session. We will post it. But now I would like to move on to the third topic that we have for today, which are the unsolved challenges. So, is everything solved in Erlang? I don't think so. And if I'm right, then how could I, as a researcher, contribute? What are the unsolved challenges?
Well, yes, sure. There is things that could be done, could be improved. Like one topic that comes up every now and then is people asking how can I sandbox code? How can I run some code that is coming from, I don't know, a partner? Maybe I'm hosting a software as a service, and I want partners to contribute with snippets of code to customize the behavior for their particular instance, right? And so there are other languages, other platforms that offer like sandboxing functionality. So Lua in particular is famous for it, but Java also has sandboxing functionalities. And Erlang it doesn't. I mean, if once you're in a VM instance or in a cluster of VM instances, you basically have unlimited access to whatever resources this VM has access to. So there's really no other way around it. So this is, if there is a need for such functionality, first of all, you can just reach out to those external tools. You can, for example, use Lua, and you can use Robert's Luero, which is an implementation of the Lua virtual machine in Erlang, to provide that ability to customize things with code without actually running Bean code, which is, like we said, is very difficult to sandbox, or impossible to sandbox. If there is a real need for this, then maybe someone would want to propose a solution that can actually work as part of the Beam. Of course, that would have to be also done in coordination with the OTP team who maintain the Beam. I don't think this is something that you write a pull request and throw it on them. I think there, first of all, needs to be some design, some thinking about the design, and needs to be aligned with people's expectations to see if this can be done. So that's an area that I've seen crop up sometimes. Another one is code signing. So code signing is an interesting idea. So the idea is you basically restrict which code can run in your application or in your servers. And there's different ways of implementing code signing. One way is basically just to say, okay, I'm distributing my application as a tarball or a zip file, and I'm attaching a signature with it, and then you can verify it before you choose to install it. But that doesn't provide all the protections that code signing is supposed to provide, because it doesn't stop someone from maybe modifying something later on the machine and then having that code executed. So ideally, the code signing also protects code loading from like the loading of arbitrary code. You only ever load code that has a signature that can be verified against a public key that has to be then securely injected, because if you can swap out the public key, then of course the whole code signing becomes is compromised. But if the Erlang code loader could have like a hook to verify a signature on a Beam file, that would provide some additional protections. If you're running in embedded mode in a release, then you normally don't load code at runtime anyway, but still, even at the startup phase of the Beam, it would be nice to verify the Beam files for integrity and see that they come from a trusted source.
Right. Okay, so these two topics, yes, these are very so to say academic topics with, of course, real contribution to the community. But if I just want to have my hobby project as an engineer and I care about security, then what could I do? Could I influence something that's missing?
Well, I can think of areas where I suppose I can't speak for the OTP team, of course. Maybe I'm okay, but I know that there are some areas where there's room for improvement. That just the OTP team doesn't necessarily have the bandwidth or the priorities to address. One area that came up not so long ago is OCSP. So OCSP is the online certificate status protocol. It's a way of verifying whether a certificate that someone sends you, for example, during a handshake with a TLS server, you get the server certificate and you want to check if that certificate has not been revoked. So the old way of doing that would be to check it against the certificate revocation list, CRL. That has a lot of issues. Distributing CRLs, it's cumbersome, it's expensive. And so OCSP was supposed to address those concerns, and especially OCSP stapling. It's another extension of the TLS handshake that allows the server to basically provide OCSP status information in real time. Solves many of the problems of revocation in PKI. Not all of them, and we can have that discussion as well. But so OCSP is like the de facto standard for certificate revocation checks, and there is some work has been done in OTP, but it's marked as experimental, and I've looked at it. It's not really there. It cannot be used right now, and it would be very good to have. So if there are smart people around who have spare time and want to contribute to it, I'm sure that there some contributions in that area could be appreciated.
Right. And if I would like to work on processes, and it's not Erlang processes, then do we have some? Yeah, right. Okay. So I'm thinking about vulnerability reporting. I think it's really not. Well, yeah. It's not really worked out right now, right? So it's we could get better there as a community.
Right. So I mean, obviously there are like global platform independent processes for vulnerability reporting, CVEs in particular, and some vulnerabilities in Erlang itself or in packages on Hex do have CVEs assigned to them. But I think you can see in other ecosystems like Node.js or Ruby, Python, that there is value in having something in the community that basically provides a centralized place to report vulnerabilities, to provide information, trusted information about available like known vulnerabilities. Also to make sure that the tooling, that whatever tooling you put in place, that it can reliably identify packages. That's part of the problem sometimes. It's like, okay, we know that there's a vulnerability in a certain version of a certain package, but how do we tell the tool to reliably identify that package and that version? Especially CVEs are very bad at actually identifying what software. I mean, it might work for big, commonly used software projects, but when it comes down to hex packages or even individual applications within the OTP like distribution, it's not very accurate, and that can be a problem. So there, I think there is room there for, and maybe the Erlang Ecosystem Foundation, the security working group, can play a role there. We need people who like to work about processes. Exactly.
Our time, we are out of time, unfortunately, but let's continue this discussion in the token launch. Thank you very much, Jerome, for attending. I really enjoyed this discussion with Bram. Thank you.